the second part of the exam. I'm going to go through the multiple choice calculator section. You're supposed to have 45 minutes for this. I'm going to be using Desmos rather than the graphing calculator because I don't really have a great way of recording the graphing calculator with my camera. Sorry if that feels like I'm cheating a bit, but yeah. Okay, so the first problem is number 76. The graph of f prime, the derivative of the function f is shown above for x between -3 and +3. On what intervals is f increasing? Well, since we have a graph of f prime, we should think about what it means for f to be increasing in terms of f prime. F will be increasing when f prime is positive. So you just want to know, when is this graph positive? And that looks like between -1 and 2, and also 2 and beyond. I guess technically not including 2 because the derivative is like 0 at 2, so strictly speaking, maybe it's not increasing at 2, but certainly -1 and beyond. So, so it looks like -1 to 3 is the right answer, right? On -1 to 3, f prime is positive. So that's number 76. Number 77. The rate at which water leaks from a tank in gallons per hour is modeled by R, a differentiable function of the number of hours after the leak is discovered. Which of the following is the best interpretation of R prime of 3? So think about this. R itself, the original function, represents the rate at which water is leaking, right? So R is already a rate. It's already something like gallons per hour. So if you take the derivative, that's going to be the rate of change of the rate of change. It's a bit like acceleration, I suppose. So let's see which of these options makes sense. A, the amount of water in gallons that has leaked out of the tank during the first 3 hours. No, that's what you'd get if you integrated R from 0 to 3, right? R is kind of like the rate out. If you integrated R from 0 to 3, that would give you the amount of water. B, the amount of change in gallons per hour in the rate at which water is leaking during the 3. No, the amount of change, no, that's definitely not right. That would sort of, yeah, no. The rate at which water leaks from the tank in gallons per hour, 3 hours after the leak. Again, no, that sounds like what R already is, right? Like R is already the rate at which the water is leaking from the tank. So it's probably going to be D, the rate of change of the rate at which water leaks from the tank in gallons per hour, 3 hours. Yeah, that's the one, right? It's the rate of change of the rate itself. It's the rate at which the rate of change is changing. 78. A particle moves along the x-axis. The velocity of the particle at time t is given by blah. If the position of the particle is x equals 1, when t equals 2, what is the position of the particle when t equals 4? Really quick, notice that there are decimals here. You know you're going to need your calculator for this if there are decimals because you're not getting this answer by hand. So how do you do this? Well, one way to view it is to say it's a bit like later value equals earlier value plus net change, because we can say that the later value of the position function, like the position at time 4, is equal to the earlier value of the position function, which is x of 1. Or sorry, 2, right? 2 is the time that they give you, right? Right? Plus the integral from 2 to 4 of x prime of t dt. Okay, that's like later value equals earlier value plus net change. Now, you can view it that way. It's useful to view it that way because we know what x of 2 is. It's 1, right? That's what this is telling you. And, you know, x prime, well, that's just the velocity function, right? And you have a formula for that. It's 4 over t cubed plus 1 dt. And so x of 4 is just going to be 1 plus this integral, and you should just evaluate that integral on your calculator. I'll do it here, integral from 2 to 4. So 1 plus integral from 2 to 4, what is it? 4 over t cubed plus 1 dt. 1.352, is that one of the answers? Yeah, 1.353. I guess it rounds up to, yeah, it does round up to 3. Okay, yeah, so it looks like it's C. 79. The graph of the function f is shown above. Of the following intervals, on which is f continuous but not differentiable? Watch out, these are intervals. They look like they might be points, but these are actually open intervals, right? Notice that they say intervals. So on which interval is f continuous but not differentiable? Classic example of continuous but not differentiable is like a corner of some kind, right? A corner, like this guy right here. Okay, it's continuous here, but it's not differentiable. So I'm looking for an interval which contains this guy. Not 0 to 1, not 1 to 2, 2 to 3. Yeah, 2 to 3 looks good, right? 2 to 3 contains this guy. So I would say it's C. 80. The first derivative of the function f is defined by f prime equals blah, blah, blah for x between negative 1.5 and 1.5. On which of the following intervals is the graph of f concave up? Okay, very interesting. Concavity can be analyzed in lots of different ways, right? If you had the original function f, which you don't, if you had the original function f, you could, like, I don't know, graph it and maybe look at it and inspect where it's concave up. We don't have that, and you're not going to find it, okay? If you're thinking about finding the antiderivative of this function, think again. It's not going to happen, all right? That's way too complicated. Maybe you're saying to yourself, oh, I can analyze concavity by looking at the second derivative, right? Concave up means the second derivative is positive. So I'm going to take the derivative of this guy and then see where that resulting function is positive. That would work, but that's still more work than you need to do. That's a lot more work than you need to do. You don't need to take any derivatives or antiderivatives in this problem at all, because you just have to recognize, hey, concavity can be analyzed at the level of f prime, which you already have a formula for, right? Concave up at the level of f prime means f prime increasing. So you just need to know, when is this function increasing? So just graph it and see where it's increasing. Maybe you're thinking, oh, I got to take the derivative and do a sign analysis. No, just graph it. Just graph this function, right? So it is x squared plus 1 times sine of 3x minus 1. And I'm only interested in the interval from negative 1.5 to positive 1.5, so you should adjust your viewing window on your graphing calculator so that it only displays that interval. If I look at this, okay, I want to know, when is this function increasing? Well, two places, right? This little interval here, right? This brief period of time here, from, it looks like this is from negative 1.5 up to negative 1.3, okay? And then also from here, negative 0.24 to 0.96. So those are the two intervals that I'm looking for. Is this the one? Is that the two intervals that I had in mind over here? Negative 1.5 up to negative 1.341, yep. And negative 0.24 up to 0.96. Yep, that's right. Looks like it's A. Cool. 81. During a rainfall, the depth of water in a rain gauge. What is a rain gauge? I don't know. It measures the amount of rain or something. It doesn't matter. The point is, rain's falling, and the depth of the water in this thing is increasing at a rate modeled by this function. So this is the rate of increase of the amount of water in this thing. Okay, how much did the depth of water in the rain gauge increase from 0 to 3? This is essentially kind of like a rate-in function, right? It's the amount, it's the rate at which the rain is entering. So if you want to know how much rain entered, if you want to know the amount of water that entered, just integrate this function. Just integrate it from 0 to 3. Again, you have a calculator. Use it. Don't be trying to find antiderivatives of this thing. You are wasting time if you're doing that. So I'm looking for integral from 0 to 3, 0.5 plus t times cosine of pi t cubed over 80 dt. Looks like it's 5.4. Yep, looks like it's d. Cool. 82. Let f be a function such that f of 1 equals -2 and f of 5 equals 7. This already sounds like... Oh, I was going to say it sounds like earlier value and later value, but it's not. Which of the following conditions ensures that f of c equals 0 for some value c in the open... Yeah, you know this is one of those theorem problems, right? This is surely like an intermediate value theorem or a mean value theorem or something like that. So this is asking about the original function taking on a particular value. That to me sounds like the intermediate value theorem. The mean value theorem is about the derivative taking on a certain value, right? This is about the original function, so I think it's intermediate value theorem. So yeah, 0, of course, is an intermediate value between -2 and 7. And so the intermediate value theorem says if this function is continuous on the closed interval 1 to 5, then it will take on the value 0 somewhere on that interval. So the function needs to be continuous, right? So it's going to be C. 83. The acceleration of a particle moving along the x-axis is given by blah. At what value of t is the particle's velocity decreasing most rapidly? Okay, well, let's think about that. This function here is the derivative of velocity. So velocity decreasing means this guy is negative. And velocity decreasing most rapidly means this guy is most negative, like as negative as it possibly can be. So I'm just going to graph this function. I'm just going to graph t minus 8 sine t. And I'm only interested in the interval from 0 to 8, so make sure you restrict your window on your calculator. So that's what it looks like. When is it most negative? Here. So you would use calc minimum to find the x-coordinate of this point. So that is 1.42, which, yeah, looks like it's B. Cool. 84. Do you notice, by the way, like, look how little work I've actually done, right? Like, it's all, so much of it is just in the calculator. Anyway, 84. If the average value of the function f over the closed interval 2 to 4 is 3, and if f of x is greater than or equal to 0 for all x, what is the area of the region enclosed by the graph? Blah, blah, blah. Well, the average value of the function f, in general, the average value over the interval a to b is 1 over b minus a times the integral from a to b f of x dx. That's the average value formula. We're told that the average value of this function over the interval 2 to 4 is equal to 3. That means that 1 over 4 minus 2 times the integral from 2 to 4 f of x dx has to be equal to 3. Which just means, of course, that 1/2 times the integral from 2 to 4 f of x dx is equal to 3. Which means that integral, the integral from 2 to 4 f of x dx, is equal to 6. Like, just multiply both sides of that equation by 2. Now, why is that useful? Because that integral is precisely what they're asking for here. They're asking for it in kind of a stupid roundabout way, but that's what they're looking for. Think about it. The area of the region enclosed by the graph of f, the lines x equals 2 and x equals 4, and the x-axis. Yeah, that's just the integral of f. One thing that you might worry about is, like, how do you know that, that's really true? The thing is, they tell you that f of x is always positive. So you have no idea what f looks like, okay? No clue. But you know that it's positive. So maybe it's some big, complicated, blah, blah blah, 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 crazy, complicated thing, but it's positive, okay? But it's always positive. So you know it's always above the x-axis. And so therefore, the area of this graph, whatever it looks like, the area bound by this graph, the lines x equals 2 and x equals 4, and the x-axis, well, that's this region right here. And that is just the integral of this function, right? So the integral of this function is 6, so the answer is 6. Getting a bit noisy in the hallway, but I might close my door. Give me a second. Okay, 85. The function f is continuous and increasing for x greater than -1. The table above gives values of f at selected values of x. Of the following, which is the best approximation for what in the world? Limit as x approaches 0 e to the -2 f of x. Say what now? I gotta say, I don't think I've ever seen a problem quite like this. So what is this asking me for? So it's asking me for an approximation of this limit, right? Limit x approaches 0 of e to the -2 f of x. So ideally what you'd like to do is plug in 0, but you don't know what f of 0 is, right? You don't know what f of 0 is exactly. So if you could, you'd sort of plug in 0 and you'd get this. And you'd look at the table and you'd be like, oh, well, f of 0 is this, and that's the value of the limit. But you don't know what f of 0 is, right? You don't know what it is. And so therefore, we need to use the table. Now, as you can see, as x approaches 0, right? In this table, x is approaching 0 from the left here. Like, see how these values are getting closer to 0 from the left? And see how on the right, the x values are getting closer to 0 from the right? As you can see, it looks to me like the value of f is approaching 0, right? Like, it looks like the value of f is approaching 0. So it looks to me like as x approaches 0, the function f also approaches 0, which means that this limit is really approaching e to the -2 times 0, which is just e to the 0, which is 1. So that would be, I think that's my best guess there. Okay, let me reopen the door in the hallway. 1 second. Okay. 86. Let R be the region in the first quadrant bounded by the graphs of blah and blah, as shown in the figure above. The region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in region R. What is the volume of the solid? Well, as with every volume problem, you just need to write down the cross-sectional area formula and then integrate it. So the cross-sections, we're told, are what kind of triangles? They're isosceles triangles, right? Of course, any triangle, the area is 1/2 base times height. But if you think about it, because this is an isosceles triangle, an isosceles right triangle, actually, that's important. Because it's an isosceles right triangle, if you draw a picture, I hate the drawing. Oh, I don't have permission to do this? Oh my God, so stupid. Whatever. Well, an isosceles right triangle, if you imagine an isosceles right triangle, the base is the same as the height, right? Which means h is equal to b in this formula, and you get the area is 1/2 b squared. So that's sort of my prototype for the cross-sectional area formula. Now, what is B in terms of like x, y, or whatever? The cross sections are perpendicular to the x-axis. So, the triangles are going this way. And the base of the triangle is just, this line segment here going between the two curves. So I think the base is simply the top curve minus the bottom curve. Which one is which? Pretty sure that the top curve is the cosine function, right? Like, because this is like a parabola that opens up. If you wanted, and so I'm pretty sure that x minus 2 squared has got to be this one. Of course, you could check on your calculator if you wanted to make sure. But anyway, so I think that the cosine function is the top one. So b is going to be cosine of pi x over 4 minus the bottom curve, which is the quadratic x minus 2 quantity squared. So that is your b value, right? And that means that my cross-sectional area is 1/2 that whole thing squared, right? Which means that my volume is going to be the integral from 0 to 2, right? X value 0 to 2 of this whole thing right here, dx. And I'll compute that on my, on Desmos. So integral from 0 to 2, 1/2, 4 cosine pi x over 4 minus quantity x minus 2 squared, all quantity squared, dx, 1.77. Yeah, that looks pretty good. 1.775 looks like it's A. Okie dokie. 87. Let f and g be continuous functions if blah, blah, blah. Yeah, once you've seen enough of these problems, you can recognize them right away. You got to use integral properties, right? So this integral that they're asking you to compute, integral from 2 to 6 of 3 f of x plus g of x. I'll just write f and g. You can distribute, right? You can distribute the integral. That's the same thing as the integral from 2 to 6, 3f dx plus integral from 2 to 6 g d of x. And the 3 in the first integral is a constant multiple, and so therefore it can just be pulled outside of the integral. And now I get this. So I'm told that the integral from 2 to 6 of f is 5. So I know that this guy right here is 5. And then watch out, I'm told that the integral from 6 to 2 of g is 7. That's not quite what I have. I have the integral from 2 to 6. So this guy is not 7. It's the opposite, -7, right? Because the limits are in the wrong order. So that's going to be 3 times 5 plus -7. So 15 minus 7 is 8. So I say it's 8b. 88. Let f be a twice differentiable function such that f double prime is negative for all x. Okay. The graph of y equals s of x is the secant line passing through the points blah and blah. Okay. The graph of y equals t of x is the tangent line to the graph of f at x equals 4. Which of the following is true? Okay. I see what they're talking about. So basically, I need to find a way of actually drawing a picture because, all right, well, let's just draw on top of the high school schedule, right? Like, whatever, why not? Who cares? So let me just make a big old white block. There we go. Now I've got lots of room. Cool. So, what is going on? Is this gonna work? Can I draw now? That is not gonna work. Oh my god. Okay. In case you haven't noticed, this drawing program is trash. It's trash. Let's do that. Reopen it. I think. Oh my god. Why is it so hard to just draw a picture? There. Okay. I think that'll work, but I have to click over here. Anyway, okay. So, finally, this function is concave down because the second derivative is negative, right? So, looks something like this, okay? So that's what it looks like. It's concave. Oops, sorry. No, that's concave up, concave down. So it looks something like this, okay? So it's concave down, and I'm being asked to consider the secant line between 3 and 5 and the tangent line at 4. So let's say that 3 is right here, 4 is in the middle, and 5 is right here, okay? So 3, let's say that dear God, you have no idea how annoying this process is. This is absolutely crazy. Let's say that this is 5, and that means that the secant line between those 2 points looks like that. Okay, so there's the secant line. Cool. And then the tangent line at 4 would be maybe something like this, right? Like, I don't know, whatever. Okay, so maybe it's like that. They don't need to be parallel. It kind of looks like they're parallel from my picture, but we don't know that they are. It's just how I happen to draw it. Okay, so there we go. So this guy down here, that's S. This guy here, that's T. And then they want to know, they want to compare the value of the 2 lines and the original function at 4.2, which is like just past this point of tangency. So if I go right past this point of tangency, basically I can tell that the secant line has the least value, after that is the value of the actual function, and then after that the biggest is the tangent line. So it should be S for secant line, and then F, the original function, and then the tangent line. So SFT, there it is, looks like it's C. Sorry, that's not that hard of a problem. It's just, my God, is it difficult to draw pictures. How is this the default program on Macintosh? How in the year of our Lord, 2024, is the default drawing software on Macintosh that bad? Like, my God. Anyway, 89. The number of insects in a certain population at time t days is modeled by the function p with first derivative, blah, blah, blah. At time t equals 0, the number of insects in the population is 40. Which of the following statements are true? Okay. So to be clear here, p itself is the number of insects present, right? So p prime is the derivative of that, all right, the rate of change. So which of the following is true? 1. At time t equals 10, the number of insects in the population is 2840. I have no idea if that's true. I have to go and look. So I can say later value equals earlier value plus net change. So the population at 10 is equal to the initial population plus the integral from 0 to 10 of p prime of t dt. Well, I know that p of 0 is 40, and then this integral I can compute on my calculator. So integral from 0 to 10 of this guy, 0.3 t squared plus 12t plus 210 dt is 2800. So that's 2840. So I think that 1 is true. Okay, so that narrows it down to either A or D. Let's look at statement 2. At time t equals 10, the number of insects in the population is increasing at a rate of 360 insects per day. That amounts to asking whether p prime of 10 is that equal to 360. Well, let me see. So this is p prime. I'm just going to call it f of t. And what is, yeah. So that looks true. So it looks like B, statement 2 is also true. So if I were doing this on a real test, I would just be like, it's D, because 1 and 2 are both true. If you had time and you wanted to check your answers, you could also look at statement 3, like, is statement 3 also true? Well, let's check. At time t equals 10, the rate of change, the number of insects in the population is increasing at a rate of 18 insects per day. Okay, the rate of change is increasing. That's talking about the derivative of the derivative. Well, p double prime, you can compute p double prime of t, right, and plug in 10. You can, but like you've probably already got this function plugged into your calculator. So it's real easy to just find the derivative, like, numerically. So this thing here, that's already p prime. So p double prime would be this guy, 18. Yep, that checks out. So it's all 3. So it's D. 90. Selected values of the increasing function h and its derivative h prime are shown in the table above. If g is a differentiable function such that h of g of x equal to x, what is the value of g prime of 7? This is one of these problems where g and h are inverse functions. Yeah, these often come up. There's often one of these on the exam. If every time I've explained this thing, it's completely flown over your head, you should just skip it. Don't waste your time, all right? But here's how it goes. You know that h of g of x is equal to x. You can get a relationship between h prime and g prime by taking the derivative of both sides of this equation. The chain rule says we get h prime of g of x times g prime of x equals derivative of the right-hand side is just 1. Okay, so that tells me that g prime of x is 1 over h prime of g of x. Cool. And I want to know what is g prime of 7, so I just plug in 7 for x. So that gives me this. Great. So I just need to compute this expression. Well, what is g of 7? They don't tell you, not directly. Okay, they don't tell you. But the thing is, g and h are inverse functions, right? I can tell that the function h sends 3 to 7, right? The function h sends 3 to 7. And since g is the inverse function, it undoes the effects of h. That means that g must send 7 back to 3. So g of 7 must, in fact, be 3. So this is 1 over h prime of 3. And I know what h prime of 3 is. It's 5 from the table, so this is 1/5. So C. Okay, that's it. We're done. Cool.